Welcome back to the Rad Lab podcast. We have a special guest here today, a good friend of mine, Benjamin Stein. He currently works at Los Alamos National Lab as a deputy group leader, and we're going to go into all kinds of the work he's doing currently and get to know him as a human being as well. Would you like to introduce yourself, Ben?
Sure. Yeah. Thank you. Excited to be here. This is my first podcast, so that's pretty cool. Yeah. So as David Ann said, my name's Ben Stein, and I've been at Los Alamos for how many years is it now? 9 years, just about. So a little while now. I'm originally from the East Coast. I was born in Philadelphia. When I was young, we moved out west to New Mexico. So I've actually lived in the Southwest for most of my life. I did my undergrad up in Colorado, a little town called Greeley. It's a small school up there, northern Colorado, which was a great experience. That was where I first really decided that I wanted to go into chemistry. Growing up, I've always been into science. I've always been very interested in science, and for a long time, I thought I wanted to go into the medical field. And so, but then when I was in my undergrad, I was a chemistry pre-med major, and I found I was far more interested in my chemistry classes or going into the lab, which was an advantage of a small school, is you're able to get lab experience like right away. Even as a sophomore, I think, is the first time I worked in the lab. And I was far more interested in that than trying to figure out what sort of volunteer thing I wanted to do in a hospital or whatever, which you have to do to get into med school. And so I decided that, maybe I'll go to graduate school. And worst case scenario, I can always still go to med school after that. I actually have a cousin who did that. He got his PhD and then went to med school. So I was talking to my advisor, my academic advisor. I said, I was very interested in doing spectroscopy. That is, using light to understand the properties of matter, whether that be molecules or solid state materials, you name it. You can use light. And when I say light, I mean everything from radio waves all the way up to gamma rays. And sometimes you put the sample in a magnet, sometimes you heat it, sometimes you cool it. But you can learn so much about it. And I just thought that was amazing because it was just as simple as shining light on something or through something, depending on the experiment. You get a window on what's happening at the atomic level, which I just thought was totally cool. And so, as luck would have it, my advisor had gone to school with someone who did a lot of spectroscopy, particular on proteins or metalloenzymes, so proteins that have a metal in them. The one that everybody probably knows is, hemoglobin in your blood. It's got an iron in it, but it's all throughout your body. You have hundreds of enzymes that have metals in them that do critical reactions. So life wouldn't work without metals. So she had gone to school with someone who did that kind of work, and one thing led to another, and I ended up going to graduate school at UNM. So I ended up back in New Mexico. It wasn't like the grand plan or anything, but I ended up back there. And so I did my graduate work looking at molybdenum enzymes, which was pretty exciting because molybdenum is one of the few third-row transition metals that has a role in biology, but it's crucial to life. And these molybdenum enzymes, what always was fascinating to me is that the active site where the metal is has these big complicated ligands, or the molecules that bind the metal. And, nature is kind of lazy, right? It doesn't make these big complicated things unless it needs to. And these big complicated centers are conserved all the way from the simplest bacteria to humans and everything in between. So they're absolutely essential to life. And so just the fundamental excitement of that was pretty cool. And you could do all kinds of cool techniques to study these things. So I got to play with magnets and lasers and all kinds of stuff, which is just fun. You get to geek out playing with big magnets and stuff. And then when I was trying to figure out what I wanted to do with the rest of my life when I grew up, I was interested in learning about the National Lab career. And as luck would have it, there was actually someone who was in the chemistry division at Los Alamos. He's still there. He's one of the division leaders. He had come down to our lab. He had known my advisor for a long time, and he came down to do some work with us. Sometimes national lab people go to universities and do some work, or vice versa. That's a pretty common thing. So I was chatting with him. We were doing some chemistry, and it's like, oh, what's this national lab thing like? And we talked about it a bunch, and then a few years went by, and then I got closer to graduating, and I talked to him again, and he said, oh, as luck would have it, we're looking for a postdoc. So he put me in touch with Stosh, who would end up being my postdoc mentor. And we were talking, and he's like, oh, yeah, we're looking for someone to work on this actinium project. I was like, well, I've never done anything remotely radioactive, let alone actinium. He's like, well, that's fine. He says, you seem like you like chemistry, so come give it a try. And so one thing led to another. I ended up at LANL, did a postdoc there for a few years, learned a lot about radiochemistry and how to handle those highly radioactive materials, but still apply, I guess, what you'd call traditional spectroscopy to them, right? So typically with radioactive materials, you'll do what's called radiochemistry, where your techniques are a little bit different. You're working with very, very tiny amounts of material that you can't typically do bulk spectroscopy on. But we had enough of this material that it made it challenging to handle because it was so much highly radioactive material, but we could do traditional spectroscopic techniques like NMR and XAFs, X-ray based techniques and things like that. So then I decided I wanted to stay. Me and my wife loved living in Los Alamos. I liked the work. There are challenges working in Los Alamos like anywhere else, but I would say Los Alamos is like one of the nicest places you could live as a scientist, right? I don't really like the big city. And there are not many not big city places that you can be a scientist, right? So got a permanent position. There's a lot packed in there to get a permanent position. But either way, I did, and was a staff scientist for a few years. And then I moved into a half-time management position as a deputy group leader. But I still stay half-time science. And cool thing, sometimes it can be hard about a national lab, is the diversity of stuff you get to work on. I mean, it's all over the map. And the dirty secret is you work on things that when you start, you're like absolutely not qualified to be working on whatsoever, right? So I work on everything from looking at the reactivity of uranium hexafluoride to fundamental magnetic and spectroscopic studies of actinides, to looking at molecular qubit architectures. So it's kind of all over the place. CO2 capture is a recent thing we've been working on. So I guess that's a very long-winded and rambly way to start everything.
No, that's great. I think
that's where I am today.
Yeah, no, I think that's amazing hearing all of those different parts, and hopefully we can unpack a lot of that and get into some of the details. But for those listening, don't let his humbleness fool you. Ben has done a lot of amazing work. If you look into his publication history, you'll be amazed at what he's done. And I encourage you to go look at some of those papers that he's put out. And I'm excited for the talk he's going to give today. So that's on a paper he just recently published. But let's go back to the beginning a little bit.
Sure.
So I know a little bit ago. So you say you were always interested in chemistry. Mm-hmm. Was there a moment that kind of flipped that switch for you, or was it just kind of a natural thing?
So, I mean, until I got into college, I've always loved science. It's always been, ever since I was very young, I just loved science, and I always had very supportive family for that type of thing. My grandfather was a scientist, a computer scientist, but so there's always been scientists in my family, I guess. And then I had a chemistry set growing up, back when you can get good chemistry sets, right? So it wasn't necessarily chemistry, I guess, growing up, but then in high school, I took a microbiology class, which I really loved. But I think looking back, one of the things I loved most about it was the hands-on aspect of microbiology, right? You sit there working with petri dishes and everything, and I really enjoyed the tactile sensation, for lack of a better way to put it, of hands-on science, right? Because it's pretty neat to, you take a bacteria sample and you grow it, and then you got to scoop it off and everything. And then when I got into college and I was doing chemistry, I just loved working in lab. It sounds a little corny, but I love the sounds and the smells and all of that of working in the lab. And I loved making measurements because you get to work with instrumentation. And it still, to this day, it's so cool. You put something that you made or somebody else made usually in the instrument, and you push some buttons and you get a squiggle on the screen, right? And there's so much in there to unpack about it. It's still what kind of gets me up in the morning, is getting to do that kind of thing. So I don't get to be in the lab as much as I wish I was, but I still get to do that. And so that's the high point of the week, getting to do that work. So the moment it was chemistry, I had a great general chemistry professor in undergrad, Dr. Clark, and he he just made it so approachable. And then the lab experience was great. Being at a small school, they were small classes, small labs, so there's lots of interaction with the professor. And really, it was like the first week of undergrad, I was like, I really want to do chemistry. So I was a chemistry pre-med major, and I switched it right away to just chemistry, because it was just a few extra classes, and it's like, well, it's a real grown-up chemistry degree that I could take and go into chemistry with if I wanted. But you could still get into med school if you needed to. And then once I started doing the undergrad research, I was pretty hooked at that point. So.
Yeah, and you make a great point about going to a smaller university,
right,
and being able to get that experience so much quicker than maybe at a big university where,
right,
maybe the PI is not as hands-on and not willing to take on undergraduate students as readily,
right,
because there's so much more on the line, I guess, for them. But no, I think that's a great point. So if you're looking into, for high school students or anyone who's looking at going to college, really consider the possibilities that maybe a smaller university, TTU is fairly small. We provide a lot of experience for our students here, and any small school will hopefully do the same. So that's a great point about, those smaller universities really give you a lot of opportunity to do what you want to do. And so I was going to ask you about the med school, because a lot of students go into liking science and want to be a doctor, and struggle with that decision.
Right.
But it seems like for you, it was just you started doing it, and it was a no-brainer.
I think so. And I mean, if we're being brutally honest about it, from a strict career standpoint, medicine's a better choice. That's just the reality of it, right? So science is definitely something you want to do if you really love it, right? Because it's hard. It's a slog a lot of the times, right? The practical or logistical aspects of it can be really challenging, and you're not going to make as much money as a scientist. That's just also the truth of it. But it's pretty cool. I mean, oftentimes I haven't met many scientists who are like, "Gosh, I sure wish I went to med school," and I have a lot of doctors in my family, physicians, I should say, and every once in a while I'll talk to them like, gosh, I'm kind of jealous. I wish I had done more science and stuff like that. Some of that might just be the grass is greener somewhere else. It's hard to know. And every job is going to have its challenges and struggles and frustrations. But, it is still something, like I mentioned before, that I just, it never gets old for me doing it. I mean, writing proposals and quarterly reports and doing budgets, that gets old sometimes. But that's just what you have to do if you want to do it, right? That's just, the price you got to pay. So,
yeah. No, that's definitely the price. I'm starting to pay that price now with all the writing, and I sometimes wish I could go back to being a postdoc and just only worry about getting in the lab and working with, cool material and
Yeah.
everything. So let's move a little bit farther. So you went to UNM for grad school, right? Sounds like you had a great experience
I loved
there.
it.
Yeah.
Yeah.
So yeah, UNM.
Probably stayed too long.
Your PI probably loved that though.
Yeah.
So, but it seems like your PI was very supportive of you moving forward in your career. Which, if you're going into grad school, make sure talk to those students, see what PIs like, what they're like, and see if they are wanting to push their students forward and not holding
Right.
people back. That's a big point, and probably one of the main factors you've been so successful is having someone so supportive in your career. And so I like to ask this question because it gives perspective for students who are going into a PhD program, what kind of skills they may want, right? So if you were to do your PhD all over again,
Right.
lose all your skills, what's the one skill you would take back with you that you could?
As boring as it sounds, probably time management. Lab skills and everything are crucial to success in science, especially at the graduate level. But there's always something new and shiny to look at, right? So being able to stay focused on something, because at the end of the day, the nature of science is you have to produce, right? You have to publish, whether it be publish or report to your sponsor, whatever the case may be, you have to produce some work product, right, at the end of the day. And boy, it's so easy to get distracted. It's like, well, instead of working on this paper, I could go try this experiment I wanted to try, right? And there are only so many hours in the day, and you can't make up for that all the time by just working more hours, right? You got to take care of yourself. You'll naturally probably work a lot more than 40 hours a week in grad school, but that's just because you love it. But at a certain point, you become less productive. And so you have to figure out your time management, which to this day is something I struggle with. I don't think anyone ever figures it out all the way, but being able to do that not perfectly, but effectively, I think is just so important. If you manage your time right and you do the things you have to do, it frees up time, right? You have just as many hours in the day as anybody else does. So being able to manage it well gives you that time to do the creative mess around in the lab type things that oftentimes lead to really cool discoveries, right? So
Yeah, no, I think that's a great point. Time management is one of those things that you learn it. You try to learn it in undergrad. You try to learn it some more in grad school, and you're always trying to be better at it. Because especially when working in a lab setting, if you think an experiment's going to take you an hour, it usually takes you 3 times that.
Oh, at least.
At least, there's always you could be the most prepared possible.
Right.
Like, I've done this experiment before. I know how long it could take, and you get in there and just something happens.
Yeah.
Right. And so,
so being okay with failure is probably a close second, because far more of the things you do in the lab are going to fail than things that are going to work, right? But a lot of times those failures it's working, it's just not the way you expected. So there's a bit of that ego management, I guess, that you also have to work on. Because you see it a lot, people getting into the lab for the first time, they're like really academically successful and they've always got good grades, and they go in and like the experiment doesn't work, and they're like, what? I'm a failure, what have I done? And it's like, no, this is just how it works. And so embracing that wholeheartedly is pretty important too.
Yeah, you'll have a better mind state, or a state of
Right.
mind, if you accept
Right.
failure a little bit easier.
Yeah.
Because, man, it's like 95 or more
Oh yeah.
% failure. And then,
Instruments break, your hot plate doesn't work right, or your stir bar stops stirring, or who knows, all kinds of things go crazy. And you being able to like stop and take a minute and troubleshoot and figure out what's going on, And again, right, there's, I don't know how many times like something hasn't worked right, and then I stop and look at it. It's like, boy, that's interesting.
Yeah.
I didn't expect that. And then that leads you down all kinds of interesting rabbit holes. So,
Oh, yeah.
Science isn't always as clear cut as like I set my hypothesis and I do my experiment and get my results. I mean, you'll have a hypothesis of what you think is going to happen, and it doesn't happen, and then you go down that route, right?
Mm-hmm.
So just stay curious, I guess.
Yeah, no, absolutely. You know, a failure means something new happened usually.
Right.
Because, right, if you knew what was going to happen all the time, it wouldn't be new.
And where'd the fun in that be?
Yeah. Right. It feels good, but but there's definitely a lack of fun for sure. So, PhD, you went on to do a postdoc at Los Alamos. You said that was the first time you were introduced to working with radioactive isotopes. Yep. So, what do you think was the biggest hurdle of getting into radiochemistry?
So the thing with radiochemistry, you mentioned a minute ago that things are going to take 3 times longer than you think. Radiochemistry, everything's going to take 10 or 20 times longer. Everything is very slow. And I was struck also by how low tech it is. Say you're doing something and you're like, boy, I wish I could rotovap this. No, you can't rotovap it because you'd contaminate the whole rotovap and you're done. It's like, well, I need to evaporate this, so I'm just going to put it on a hot plate and blow air over it, right? And you throw everything away. So it's all very low-tech lab work in a lot of ways, and it's very slow. You have to be very methodical. Working with any chemicals, you don't want to be splashing them all over the place, of course, but with depending on the isotope you're working with, the definition of splash that's a problem can be very different. Like a small bubble popping, when you're using your pipette, can spread a huge amount of radioactivity all over the place. And so that change in how methodical you have to be was really big. Or putting a sample in a cuvette, right, is a whole process. And you almost always are working with a second person, so there's a lot more planning. You got to make sure you have your person there, right? You got to talk to the other people in the lab to make sure they don't need this one particular capability at the time. And so there's a lot more organization around it. So that was the biggest change to me. I had done lots of reactive chemistry before with pyrophorics and things like that, which are its own set of challenges. Some of the, I guess, quote-unquote advantages with those types of materials is if you messed up pretty fast. Radioactive material, you don't know until you check with the meter, right? It's like just a little bubble pops, and you can have activity all over your lab coat. There's no immediate feedback that happened until you checked yourself, right? So that's a big change, I think.
Yeah, no, that's a great point. I never thought about, the change of pace that you have to do things at, and you have to be a lot more methodical and, really a team player, right? Because the person you're working with, usually you kind of, you find the person you like working with, and that usually turns into your second a lot of the time. And just, building that relationship and, they know what you want, how you want things handed. Like just handing something to someone in a hot hood some people like it, like to be handed things very differently, right? Even those little small things, like just make radiochemistry such a different experience in the lab.
And being a second is an interesting thing too, because you're there because they're there working on what they're working on, and you're there to hand them things, obviously, but also keep a second pair of eyes. So there's more of that bearing your ego, because they're there to tell you, like, hey, you brushed your arm up against this thing, right? And they're not criticizing you. They're just your backup to help you when you make mistakes that you don't notice, which we all do. I mean, it's very easy to brush your arm against the inside of the hood or reach in too far, right? And like, hey, your face is getting a little close to the entrance of the hood there. And so you're there to watch out for them when you're working as the second. That's a pretty important job too. You're not doing the science, you're just keeping an eye on your buddy there. And so that's a very different, you don't usually do that when you're doing chemistry,
anything
right?
Else,
So that's a change too. But it's fun because you have some of my best memories are working in the lab with say Marilyn or Justin or someone like that, and you bantering back and forth, and you're joking and you're having a great time, but you're doing really cool science, and so there's far more of that teamwork, which is pretty cool.
Yeah, and a lot of other disciplines, you don't have that teamwork. You have your own hood.
Yeah.
You do your own kind of experiments, and you're kind of on your own.
Right.
But it's so nice having that other person, because they're not just there to keep an eye, like in the ego thing you mentioned is a big deal, because you can't have an ego
Right.
with it, because they can tell you to stop if they need to, because it's about being safe, right?
Exactly.
But bouncing ideas off of them, like so many ideas have like been born, at least for me, just we're working and we're waiting for something to dry or something like that, and you're just with your partner and you're just talking about science and talking about different things, talking about the experiment you're doing, and like, oh, we should change this, or we should do this next time. It's just, I couldn't imagine doing chemistry another way, because it's just so much more. I think it's personally just so much more fun this way. Yeah. So,
and it's nice to have that backup there, right? Just to both for what the ideas come out of when you're sitting there working together in the hood, and just that sense of being part of a team is oftentimes missing in science sometimes, right? I had a lot of days in grad school where I was sitting in a room by myself in the dark with a magnet. I didn't want the room lights interfering with my data collection, for hours and hours and hours, because when we had liquid helium, someone better be in there running the magnet, right? And so those were some of the few times we did like overnight types of experiments, and it's kind of lonely sitting in there in the dark by yourself for 12 hours.
Yeah.
So,
yeah.
But you don't do that with rad work. That's another thing, is like, it's pretty 9 to 5, because outside of those hours, you don't have any of the institutional support. So if something does happen, you may be sitting there waiting for a while. So it does put, and of course, if you go a little later, no one wants you to rush, right? But so you have to plan your day a little better, right? You can't be like, oh, I'll wander in after lunch and maybe putz around for a bit. You don't get to do that. It's like, okay, we're going to go in at this time because we need to schedule an RCT, the radiological control technician, to be there at a certain time to move our sample around. So the logistics of it are a little more complicated. Or shipping samples to a synchrotron, right?
Yeah.
Or to a magnet lab there's paperwork you got to do just to ship the sample, and you got to plan the shipper to show up at a certain time, and the RCT to prepare the shipment. So it forces you to be a lot more organized than you may naturally want to be.
Would you say radiochemists are more organized than other scientists?
Probably by necessity. With the logistics of it, certainly.
Yeah.
I mean, like organizing with other people and things, you just have to. Even just the paperwork.
Yeah.
There's a lot more. Like, you ship normal samples, half the time you don't have to do much paperwork at all. So you're forced to do that. You don't get to do as many experiments in a X amount of time, but it kind of reminds me of like the old days of chemistry. You see someone's whole PhD was like one crystal structure, right? In radiochemistry, you can do, you do one spectroscopic measurement on a compound. There's a huge amount of work into that measurement, and that's your study, right? It's not like, oh, I made 15 ruthenium compounds.
Yeah.
It's not like one is more or less work than the other. It's just the scope is usually a lot tighter, just because of the nature of the work.
Mm-hmm. No, absolutely. So you got your feet wet in your postdoc, and you wanted to stick around at Los Alamos. So give us the highlights of Los Alamos and what ultimately really made you stick around.
So I think the thing I really liked the most about it was the diversity of science there. Los Alamos is a huge place. It's 14,000 people. And so that's, a good sized university, but it's not mostly students. It's all scientists or technicians or administrators or managers, right? So the breadth of science that's happening there is really cool. I mean, there's still, to this day, I'll go meet somebody and it's like, I've never been in this part of the lab, right? I've been there almost a decade and it's like, oh, I don't even know where I am. And so that's pretty cool. And if you're someone who's willing to branch out, you can get involved in so many different things. Like I mentioned, the CO2 capture. I've never done CO2 capture, but on another note of that, though, sometimes it can be overwhelming because you're like, well, what am I going to do with my life here, right? And finding a permanent position, at the end of the day, it comes down to money. You got to have enough money to pay for yourself, and that may range from I'm going to go work on an established program that's involved in, say, the weapons program, and that's more of a traditional, there's a job posting and you apply for it and you get hired, and they're like, here's the project code you charge, and you work under a much more structured kind of organization. Some people at the lab, though, go a route where it's more entrepreneurial, and it's just, hey, I found these pots of funding that I can work on. And that changes year to year, every few years, because funding comes and goes, and so you have to be willing to be flexible. And, over time, you get more expensive over time in a national lab. I heard someone to refer to it as anti-tenure, where it gets harder to stay the longer you're there. So what you see is a lot of people, they'll spend part of their time doing some kind of management thing, whether that be line management or program management or something like that. But I guess to pull it back a little bit, when I was first looking for a permanent position, there was some pots of money that were available to help me convert. And then I spoke with the person who would become my group leader, and he had a project. He's like, hey, I need someone who's got a spectroscopy background to contribute to this project, and he could fund a good chunk of it, right? You don't want to spread yourself too thin. You don't want like 20% gigs, right? You want to try to compress it as much as you can, because there's a cost, right, of shifting gears too much, right? It takes you X amount of time to go and work on another project. So that all started, and during that time, I also was lucky enough to get some independent funding, which has sort of changed over the years, and different stuff has come and gone. So I guess the piece of advice there is, if you get to a national lab and you want to stay, you have to be pretty open-minded about what you're going to do, right? And that carries through your entire career at a national lab. Because I don't know much of anyone who does what they used to do. So you have to be flexible.
But like you said, that's the fun in it, right?
That is the fun. I love it. I mean, maybe I'm a little ADD, where it's like, oh, I want to try something new. But you can do that at a national lab, right? Even if you're like, well, I haven't really done that before, but people are usually willing to let you give it a whirl, right?
Yeah.
So I think that's a big thing. And it depends on the lab, right? There's lots of different national labs. Some are much harder to get permanent positions at. LANL, if you really want to stay, there's a good chance you'll find something, right? The odds are very good. Some of the other labs are smaller, and they're much more constrained on how many new people can come in. So a lot of times you may be at a national lab and there's just no possible route forward to staying there, and you have to look at a different national lab or academia, whatever the case may be. So everybody's experience is very different at a national lab. So, but in general, it's just a matter of identifying the program that can cover your time and talking to the people who manage that and getting them to give you a shot as you go, right? So,
yeah, and I think LANL does a great job of bringing in postdocs, bringing in postdocs. There's so much opportunity for all levels of chemists or scientists, right? And What are some ways that if someone's thinking about Los
Yeah.
Alamos as a possible summer gig, or they want to postdoc there, what do you think is the best way to try to get their foot in the door?
So I'll send you a link. We actually have like a recruiting
I'll put it in the
link,
description of
like
the video.
a QR code even. We're very high tech now. So we have students all the way from high school and up, right? We have undergrads. We have what are called postbacks, where they finish their bachelor's, but they haven't started grad school yet. Then we have master's students. We have postmasters. We have graduate students. Obviously, we're not a degree granting institution, so it's always students who come from a university to do. Usually, it's like, hey, I want to learn how to do this technique. LANL has this technique. Or I did this thing with uranium at my home institution. I want to do plutonium, and they'll come to LANL for a year and do those experiments. And then, of course, there's postdoc, right? So what the easiest thing to do, there's just a jobs page at LANL, and there's job postings. The trick can be there's like general job postings, which are just like physical sciences undergrad intern, which is usually a huge job posting, and your application can get lost in the noise, right? Because there'll be tons of people applying to that. You want to look for the more specific ones, right? And don't be discouraged if you look and you're like, oh, I don't know how to do this acronym of a technique, right? Most scientists there, I can't speak for all of them, but I'm usually looking more for people who are excited about science and they're willing to try, right? Whether or not they know exactly what I need them to do is almost secondary. We can teach you how to do that, but I can't teach enthusiasm and tenacity. Don't have enough time to teach that. But I can teach you a technique, right? Even if you've never handled radioactive stuff, we can teach you how to do that. And be proactive. Reach out to that particular person, because everyone at LANL is oversubscribed and gets hundreds of emails a day, right? So if you can make that personal contact, or look around in your department, see if anyone knows someone at the National Lab, right? That's how I ended up there. So that's probably my best advice. Also, there are different programs available at the National Lab. Some of them are more formal, certain summer programs, and those ones are pretty good at, if you apply, someone will reach back out to you. They're usually like a more focused, how do you want to say, like topic area. So for example, there's the Seaborg Institute. They have graduate internships available. And those are great because they come with funding. So the PI doesn't have to figure out how to cover you out of their budget, right? So those would be my recommendations. If you go to the website, it's jobs.lanl.gov, you can sort by postdoc or student or whatever the case may be, and your major area and that kind of thing, and just look around a little bit. And then there's a lot of good information on the site in general about the different groups and the people in the groups, and don't be shy about reaching out to someone. Student emails me and is curious about something. That's a much more interesting email to respond to than most of the stuff I have to deal with.
Yeah, no, I think reaching out is a big thing. Like, if you're a student out there, don't be afraid to reach out.
Yeah.
Like, we're more than happy to speak to students and talk about research
Right.
with a student. Like, that's probably one of the better part of our days, than sitting in a meeting somewhere.
And lots of times, a student will reach out and be like, hey, I'm not really looking for a student right now, but let me shop your CV around a little bit, and I'll send it out to other people in the group or people I know are working in that area. And I'll say, hey, this student reached out. And a lot of people are interested. It's like, oh, they were motivated enough to just reach out to somebody. So we'll shop CVs around when we get them, right?
Yeah, absolutely. And also, don't be afraid to try something new. If you're doing something in undergrad, in your undergraduate research, that's the time. If you're going to do something post-bac or before you go to grad school, that's the time to try something new. Or postdoc is the time to try something new. And I think, that's the fun of it. You're not going to be able to reinvent yourself too many times in your
Right.
career, and those are very easy times when
Yeah.
you can get that experience and try something new.
I mean, I talked about the diversity of projects I work on, but my contribution is all spectroscopy focused, right? If I woke up one day and I was like, boy, I'd really like to get into natural product synthesis, it's probably a little late for that. But I guess that's an advantage of spectroscopy is you can work on a lot of different things. But don't be shy if you're doing undergrad research and you don't like the particular thing you're working on. You're not going to hurt your advisor's feelings if you're like, I'd really like to try something else. They will probably be your biggest advocate on trying to find something else for you to do. So it's easier said than done sometimes because you don't want to disappoint people, right?
But they know the difference between someone who loves what they do and someone who's just doing it just to do it. Right. And, it's more enjoyable for both parties, I think, both sides of it. So I think, I think you touched on it a little bit, but, last question here before we have to wrap things up, when you're looking at these students and, or bringing on a postdoc, what is the one skill that you really look for in those students?
So it's definitely enthusiasm and tenacity. One of those valuable things in spectroscopy anyways, it's valuable everywhere in science, but the fear of failure or making a mistake, we work with a lot of complex instruments. I mess it up all the time, push the wrong button or whatever, turn the wrong valve, it just happens. And just like picking it up and moving forward, or the willingness to just get in there and figure out what's going on. I remember I had a student once and it's like, oh, this instrument's not working. It's like, oh, come take a look. And we were fussing around and we got it working. He's like, how'd you know how to do that? I was like, I had no idea. I just started tinkering with it until it worked. And so that's important. Now, of course, there's a lot of experience in that tinkering, that led up to that, but just don't be shy, right? Now, which isn't to say you should go in and be unsafe and all that kind of stuff, but you learn pretty quickly on how to tinker in a safe way, do something you're not sure what's going to happen, but you can bound your safety hazards a little bit. So that's the most valuable thing to me personally. And someone who's willing to be like, Ben, that's not going to work. That's a terrible idea. We should try this instead. So someone who's got that confidence, which takes a little while. Sometimes you got to pull it out of people, but that's part of the job as the mentor, is to make them feel comfortable enough to be able to say that to you. Because especially with postdocs, when I bring in a postdoc, I bring in someone who knows how to do something I don't know how to do. So I recognize and try to make them realize that I recognize that they know more about that than I do. So I'm here to listen to them. So I think those are some of the most important things to me. Because again, I can teach you a particular technique or how to do a reaction or whatever the case may be. But having that excitement and willingness to fail is the most important thing by far.
Yeah, and I can attest to the tinkering. I've seen you tinker on things, and and it's like, what happens if we just turn this knob?
Or oops, that was the wrong way.
Wrong way. It is true, and like usually with instrumentation, if you're allowed to do it, it's usually not going to hurt the machine, right? Unless you're going in there doing something that wasn't something you could adjust, right? So that's a gauge at least. If you can press that button, it's probably not going to destroy the machine. It just might not do what you want it to do.
Right, exactly. There's very I have broken machines in big ways before, but there's generally very few things you can do to break a machine, short of pushing it off the counter. And part of my job is making sure it's set up in a way so that you can't do that. And if you find a new way to break it, that's exciting too. It's like, oh, I had no idea you could break it that way. So I try to make people feel comfortable with that. So. But they have to feel comfortable with it too, and sometimes that takes a little bit of work. Yeah,
and that takes time. It's just getting used to that kind of environment. I think takes time, and takes time to build up that confidence for sure.
Yeah, absolutely.
Yeah,
and again, that's our job as mentors, is to make people feel safe to do that, right? And that's something you should look at in if you're looking at grad school and stuff, talking to other people in the group. what's the environment like? Because I think that the culture in a group is more important than the scientific prowess of the group, right? Because I've found that a single lone genius that nobody wants to work with is going to get a lot less done than a team of people that are sharp and work together well. And plus, you just have a better time there, right? So you only get to live once, so you shouldn't be miserable the whole time.
Yeah. No, I think that's a great point about, when you're looking at different things and looking at different places to work, that culture and that person you're going to work for, if you enjoy that person or enjoy the people you're around, it makes life so much easier.
So national labs in particular, LANL, it's a very lonely place if you don't have friends, right? Because again, I talked about the funding challenges at LANL. You might have a year where you're like, boy, none of my proposals hit. And you might be, this is another skill you have to learn, is asking for money. That's not as easy as you think it is, right? But if you've got people who know that you're a team player and you can deliver, you can go say, hey, I'm a little short this year. Do you need some help on a project? They'll be far more willing to help you if the funding's available, if you're known to be a good team player. So that's an important skill as well.
It goes back to the whole ego thing too, right?
Yeah.
Radiochemistry makes you check the ego out the door.
Right.
That's what I tell when I do my radiochemistry course and when I'm doing my, rad safety, spiel. I tell them anyone can tell anybody to stop.
Yeah.
And then, that's just kind of built into the environment, right? And so I think, I think that's great.
Giving people the benefit of the doubt. We all have bad days, right?
Yep.
Someone snaps when you mention that they brushed their arm, then they apologize later to let it go, right? Everyone will be in that position where they have to say sorry sometimes. So
Absolutely.
Give them the benefit of the doubt too. And hopefully they'll do the same for you when you snap at them. So.
Yeah. Well, thank you, Ben, for this wonderful conversation. I know for sure that people are going to enjoy this, and thank you for the time.
Yeah, absolutely. This was great.
Yeah. Hopefully you had fun on your first podcast.
Yeah, I did. It was definitely a new experience. So
well, now you can put it on your CV.
I know I will. The Rad Lab podcast.
Yeah, there you go.
Look at that.
Yeah, absolutely. All right.
Cool. Well, thanks again.
Yep. And thank you for listening, and we'll see you on the next one.